Hello class, today we are looking at angles and lines. So the essential question is, how do I find missing measures of angles and segments? My learning intention. I'm learning to identify vertical angles and find the missing angle measures when angles are at a point. So you've got a warm-up question here. Find x. I want you to pause the video and look and think. How will I find x? What do I know and how do I use that information? Well, I hope you did try. If not, you're not going to learn as quickly. So, as I'm looking, what I see is this is 39, and it's also the length of AC. AC is composed of AB plus BC, and the whole thing is 39. So I can set it up with addition, because it's a segment addition. 39 is equal to 9x plus 7 minus 3x plus 20. Now it becomes algebra. Combining your like terms is always your first step. I've got a 9x, I've got a negative 3x. 39 is equal to 6x, I've got a 7 plus 20 plus 27. Okay, now, what comes next? Well, just like in algebra, we've got to solve. First step is to get all the numbers to the same side. I've added 27, so I will subtract 27 from both sides. Now, 12 is equal to 6x. Last step is to divide both sides by the coefficient of x, which is 6. And x will be equal to 2. Or 2 is equal to x, however you want to put it. Okay, so when we're looking at segment addition, the whole thing is equal to the sum of its parts. The same thing will happen with angles. So, first thing we're going to look at is vertical angles. Vertical angles are angles that lie on opposite sides of each other when two lines intersect. So take a minute and look. See where your vertical angles are. Okay, so if I'm looking, I know that 2 and 4 will be vertical angles. And you've also got the other pair, which would be 1 and 3. And just looking at them, what can we say by looking at it? It looks like they are what? If you said the congruent, you would be stating a truth. So, what are a linear pair? Those are adjacent angles that sum to 180. And that's 180 degrees. So if I'm looking at 2 and 3, those are a linear pair. A linear pair form a line, and their sum is 180. Why is it 180 degrees? Because the degrees in the line are 180 degrees. That's something you need to remember. We will use it from here till the end of the school year in this class. So we're going to do a 2-column proof about vertical angles. What we want to show, WTS, is that vertical angles are congruent. Now, when we're doing proofs, WTS means want to show. What we want to show is always the last statement of our proof. The first statement, 99.9% of the time, is what is given to us. So let's look at our vertical angles up here. We know 2 and 4, 1 and 3 are vertical. Okay, just look at the diagram. What do you see in that diagram? Do you see 2 lines that intersect? Yes. Do you see the 4 angles that are created? Yes. So what we are given are lines L and M that intersect, creating angles 1, 2, 3, and 4. Now, why can we say that? This is our given information. 2 columns means we have a statement we write and then the reason for it. So the reason we can write that is this is what is given to us. Okay, now let's look at the angles. We know what do we know about lines? Well, we've got 180 degrees. What do we know about the angles? Well, the angles are linear pairs. And a linear pair means they add up to how many degrees? 180. So the next statement will be that the measure of angle 1 plus the measure of angle 2 will equal 180 degrees. They are a linear pair. Okay, are there any other angles that do the same thing? Yeah, we can go angle 2 and angle 3. They form that line. They are also a linear pair. So the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Once again, this is a linear pair. Okay, now let's think algebra. This is equal to 180 degrees, and this is equal to 180 degrees. What do we know about those two statements? If they're equal to the same thing, they must be equal to each other, yes. So, in algebra, we do a lot of replacing one thing with what it's equal to, and it begins with S. Think about that while we write this down. We're going to say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And when I replace something with what it is equal to, I am using what begins with an S. Substitution. I'm going to write substitute just to shorten it up a little bit. Okay, now look again. I've got two things on each side of the equal sign. Is anything on the two sides the same. If you said the measure of angle 2, you would be correct. The measure of angle 2 is a number. If I want to simplify and I'm adding the same number on both sides, how do I get rid of it? By subtracting it off. So I can say that the measure of angle 1 is equal to the measure of angle 3. That was subtraction. Okay. Now I'm looking at this. If these two measures are equal, what do we know about the angles? They are congruent. That's your definition. So angle 1 is congruent to angle 3 by definition. Now we have to tell our reader that we've finished our proof. The infinity sign is one way to do it. QED is another way to do it. But you always tell your reader, I'm done, I've proved it, I'm right. And that's how you tell them. So a proof sets up a statement with a reason, and the reasons have to be mathematically sound so that no one can argue or tell you you're wrong. So as you see, we worked our way through using what we knew about what was given, using linear pair, then we substituted, then we subtracted, then by definition, we were able to show vertical angles are congruent. We could go through the whole thing again and do the same thing for angles 2 and 4. So if you wanted to be probably a little bit more precise, you would say likewise, angle 2 is congruent to angle 4. That brings us to the angle addition postulate. Okay, the angle addition postulate states the sum of the measures of two adjacent angles is equal to the measure of the angle formed by the non-common sides. So it's equal to the measure of the angle formed by the non-common side. So if you're looking at the picture, the common side is that one that is part of both of them. So if I'm looking, this is my common side. The whole angle, which is angle ADC, is composed of angle ADB plus angle BDC. So what's the measure of angle ADC? Well, I know that the measure of angle ADB plus the measure of angle BDC is equal to the measure of angle ADB. Okay, so what is the measure of angle? Now we're going to substitute what we know in. What is the measure of our first angle? 36 degrees. Plus, what's the measure of our second angle? 22 degrees. That's going to be the angle ADC. So 36 plus 22 36 degrees plus 22 degrees is 58 degrees, and that is what the measure of that big angle is. Okay, any questions? Okay, let's look at finding x. We know this is a linear pair, so we know it has to add up to how many degrees? 180 degrees is equal to 5x plus 10 plus 2x minus 5. All we did was add the measures together. It is an algebraic expression, an algebraic equation. 180 degrees is equal to 5x plus 2x is 7x. 10 plus 5, 10 minus 5 is 5. So it's 7x plus 5. Now we solve. I've added 5, so I have to subtract 5 from both sides. 175 degrees is equal to 7x. Okay, last step is to divide both sides by 7. So 175 divided by 7 is 25. 25 degrees is equal to x. Okay, now for the next ones, you use substitution. If I'm looking at measure of angle ABD, it's 5x plus 3, or 5x plus 10. But x is equal to 25, so it's 5 times 25 plus 10. And those are all in degrees. 5 times 25, well, 5 quarters gives me 125 plus 10 more will give me 135 degrees. Okay, for the last one, there are 2 ways of finding it. How are you going to do it? You're going to do it the way that makes the most sense to you. So the first way would be to use the expression. So it's 2x minus 5. 2 times 25 minus 5. 50 minus 5 is equal to 45 degrees. Remember, these are all in degrees, and we should have them on our paper. Okay, that's one way to do it. What would be the other way? Well, I know that these two form a straight line. If this one is 135 degrees, how do I find the other? Well, by subtraction. The whole thing is 180 degrees. I'll subtract the 135 degrees that I found earlier, and I end up with 45 degrees. So it's 45 degrees. Which way am I going to use? Which way are you going to use? Whichever makes the most sense to you. So we have proven vertical angles are congruent. We have proven, or we've talked about linear pair, how they add up to 180 degrees. 180 degrees for a line. And we're just looking at proofs and how they work.